Hello and welcome to the second part of our third lesson in our fifth unit, Sine Functions, in our grade 11 University College math class. So we started today by exploring what the a value in our sine function does to impact its shape. How does it change? How does an a value change the way that a sine function looks? What we discovered is that the a value, in essence, becomes our vertical expansions and compressions, similar to the way it was when we were dealing with quadratics, and it also tells us when there's going to be a reflection across the equilibrium axis. So we're going to start sketching today. Or sketching rather, is sort of the big thing that we're going to be tackling in this unit. It's kind of the last major hurdle before we're done. So we're going to start today by not sketching using the table of values and really trying to nail down every single point. These are sketches, but they do have to showcase the key features of these graphs. So what I'm going to introduce you to today is a graphing method that we call the 5-point method. And you'll see it described here. Basically, it's very straightforward. It includes the three zeros, the three times that our sine function hits the equilibrium axis, and also includes the maximum and minimum values on there. So we're doing 5 points, and then we're going to kind of connect the dots. It's going to be great. Let's start first by grabbing some important pieces of information prior to sketching, and then I'll show you how we tie it all together. So let's start with our first example. We're going to sketch one cycle of our sine function y equals 6 sine x. So first things first, it asks us what our period is. Now, as I said at the outset, we don't do a lot of horizontal expansions and compressions. We really don't do any in this unit. So our period is going to be the amount of rotation before this thing starts to repeat, and that is going to be 360 degrees for us. Next, we're going to try to knock down the maximum and minimum value. Now, the maximum and minimum value of, you don't have to write this part down, of 1 sine x, which was sort of the very first one that we looked at, had a high value of 1 and a low value of -1, and that was because we had an a value here of 1. If we were to change that a value to 6, that impacts our high point. 6 becomes our highest point, our +6, and -6 becomes our lowest point. The equilibrium axis will sit right between them. So again, we can do the math on this. We can add 6 and -6 and then divide it by 2. But that will give us an equilibrium axis of y equals 0. And yes, the y equals is important, so make sure you put it down. Our amplitude is the a value right there, and that's going to be 6. Sometimes, depending on how our sine function gets moved around, our maximum and minimum values won't actually be the literal a value that you see, but the amplitude will always be the a value that you see. Let's do the domain. So the domain of any theoretical sine function is the set of all x, such that x is an element of real numbers. No limits. This thing in theory is going to go off in both directions forever, so there's no limits on it. The range, as we just looked at in the first part of this lesson, is only limited by the high point and low point of our sine function. So in this case, our high point is 6, our low point is -6. So we can say the set of all y, such that y is an element of real numbers, where, and we'll put our low point in, our y value in, our high point in. So y will be less than or equal to 6, and -6 will be less than or equal to y. So there we have our domain, range, amplitude, equilibrium axis, max, min, and period. So that's given us everything. So today we're going to look at the first sketch we can make from this information. Now the first thing I always look at is the period. How long do we have to sort of get this sketch done? And we have 360 degrees. So what I would suggest is, I've already drawn the vertical axis, the y-axis here, in for you. So I'm just going to make that 0 right there. And I'm going to use all the space I've got. I'm going to go pretty much all the way to the far side, and I'm going to call that my 360 degrees right there before my cycle starts to repeat. Halfway between, I'm going to have another point. So I'm going to eyeball halfway, and halfway through this rotation is 180 degrees. Halfway between that halfway, or a quarter of the way through our journey, is going to be 90 degrees. And the 3/4, so halfway between the half and the finale, that's going to be 270 degrees. So I've just broken this up into the places where the key features are going to happen in this graph. So the next thing I'm going to sketch on is my high point and low point. That's going to dictate the scale I put on my y-axis here. So what is my highest point going to be? It's going to be 6. My lowest point is going to be -6. So again, I'm going to use as much space as I have to articulate that. So I'm going to put +6 all the way up here at the top. And about equidistant, I'm going to put -6 all the way down there at the bottom. There's no need to add the extra gradations if you don't need them. And in this case, really, other than 0 and +6 and -6, that's all the gradation that we need. So let's get our equilibrium axis on there next. I'm going to change up my color scheme for that. It is like an axis of symmetry, sitting right here on our x-axis. I'm dotting it all the way from one side to the other, and I'm going to label it y equals 0. So these are all important things to label as we go along. And now we're just going to start putting on those key points. So the first one I'm going to put on are all 3 of the times this function hits 0. And it happens 3 times. It happens right at the beginning, happens in the middle, and happens at the end. And you'll notice I'm not putting these on the x-axis, I'm putting them on the equilibrium axis. It happens to be the x-axis, but I want you to know for sure I'm not just putting those dots on the x-axis, they're on the equilibrium axis, which just happens to be there. So at the 90-degree mark, I hit my high point, and I'm going to just put a dot about where I think that is. And then at 270, I'm going to put in my low point of -6. That happens about here. Again, it's just a sketch. And now I'm going to connect it with some curvy lines. So I always find these a little bit tough. I want to leave a little bit of a tail down here because it's important to see that this thing's going to continue. Kind of comes down. Over, oh, that's a bad start. Over to here. That's not great. I find these really tough to draw. Hopefully we get better as we go along. And there we go. So let's get some arrows on the ends. This thing, in theory, is going to continue in both directions forever. All right. Not wonderful, not terrible. It'll get the job done. So we now have the 5 points on there that we want. We're going to label all 5 points. This is important, not because I just super love labeling, but because it lets me know that if the scale of your graph isn't clear, or I'm having a hard time reading the numbers on your graph, it lets me know what exactly the points are you intended to put on there. So let's do some labeling here. So that's going to be 0 degrees at a height of 0. This one is going to be 90 degrees at a height of 6. This one is going to be 180 degrees at a height of 0. This one will be 270 degrees at a height of -6. And last but not least, we have 360 degrees at a height of 0. Oops, doesn't really look like a 0. At a height of 0. There we go. So we have all 5 points labeled. The only thing left for us to label is the actual equation itself. So that is y equals 6 sine x. And that is our first sketch using the 5-point method with all the appropriate labels and sort of modeling the style that we would put in here. Or I guess the series of steps I go through when I think about how to sketch it. So somehow I'm already at almost 9 minutes, so I'm going to stop this video here and then I'm going to do the second example. So I'll see you in part 3 for another example.